which also has a long history with the University of Maryland, to sort of conclude that. So with that, we begin the afternoon with Richard Watt. Richard.
All right, well, first, I'd like to start by saying thank you to my committee, in particular Professor Ambrose, my chair, Madam Simon, and of course Professor Hurt. Without them, this would not have come to fruition as nice as it has. I'd like to thank my parents as well for being supportive of this 6-year-long endeavor. And with that, I'd like to continue. My thesis focuses on the typical office building. The research question that I found myself asking was, how could I improve upon that model? And how could I take something that was working well and produce a better version of it for our urban environments? And when I dove into this, I realized that there were actually really 3 areas of opportunity. There's an area of opportunity for improvement at the human scale, at the building scale, and at the urban scale. And for the human scale, the aspect that came about improving the work environment of the building. How do you create a better workplace using the enclosure of the building to do so? How do you focus in on that sort of thin facade that you have typically now and turn it into a zone of something that becomes much more dynamic and beneficial to everybody inside the building? It turns out that there's actually a few studies that cover this sort of impact that a healthy workplace can have on the employees of that space. John Burns put together, he's a medical doctor, and he put together a study and research article that helps facilities managers improve working conditions for typical office spaces. And what he found was that 15% drop in productivity could be attributed to whether the building was too hot or too cold, the sun glare wasn't adequately controlled. And you can see that sort of stuff in this image here on the TV, where you see these images of, your pretty standard cubicle farm in juxtaposition with NPR's new headquarters, which is a much more open layout. So how do you take those elements and improve that from an experiential standpoint? From the building scale, it's about performance. How do you reduce the energy that the building uses? How do you produce energy with the building's enclosure? Because it's important to reduce, the building's energy usage from a cost and environmental standpoint, but leading into the urban scale, it's also important to think about how the building can then become a better steward for the city. How then do you take that and turn that into a production for the city? How do you put power back into the grid? How do you make it so that the building is not just working for itself and improving that experience, but also improving the area and site around it through air filtration, water filtration, power generation, etc. So in studying these things, I approached sort of 4 different elements or areas to focus my research and development on. Solar element that dealt with controlling light and benefiting from the sun. A wind element which looked at capturing some of the wind currents along K Street. And a plant element and an air element that looked at reintroducing plant life and filtering storm runoff and cleaning up the air quality and pollution in the city. I picked an existing building. On the site is K Street and Connecticut Avenue. The address is 1000 Connecticut Avenue. It's a pretty typical office building, 12 stories for a law firm. And the facades now of the building, as you can see in some of these images, are rather thin and flat. They lack a sort of dimensionality that they have, and it's an area of potential that I think could be improved upon. So, starting out with this particular location in this site, which interests me because I'm a local to the city and because it seems to be the perfect sort of candidate for this test of renovating an existing building. So I wanted to show that you could not just think about this in new construction, but really you could take the skin off of a building and start to look at it from there and start to retrofit existing buildings, because that truly is, I believe, more sustainable than just building something new again. So I looked at what makes the building the way it is, the different factors, whether it's economics or developer or city regulations. And then I also looked at a series of facades that started to do things like living walls and filtration systems. And a lot of them I realized did something very well, this one particular aspect. They had a living element that was a showpiece for the building or executed that wall really well. The ones that dealt with solar, they mitigated the sunlight through automated systems and they blocked the sun very well. But what a lot of these facades lacked was they didn't give anything back. So I'm hoping today to show you how it can be both ways. It can be a relationship of protection from the occupants inside and giving back to the city. Again, there's the existing building on the site, a photograph of it now. Here's some of the site images. And you can see that I'm starting with this building and effectively I'm renovating the exterior skin of this building, the enclosure, so to speak. And I start to make these cuts and intrusions in the building to add this new material to the building, and I've cut out some of the places to allow for more light to penetrate and to insert these vertical living elements, which I'll go into more detail in a second. Here's a shot of sort of those systems coming together, and then there's sort of the final product in line book. So you can see from the elevation these sort of 4 categories or elements, and I'm going to probably beat this to death, but that's basically what we're looking at: solar, wind, plant, and air, and these 4 areas of focus. For solar, it became about how to not only shelter the occupants better from the southern glare of the building, which was a particularly harsh condition. So I used programs like Visari and Ecotech to study this and sort of optimize the louvers to a point. But it also became about how to get natural light deeper into the slab. And because of the sort of rigid floor-to-floor heights that we experience in DC with the concrete construction, I looked at systems like fiber optics, which help bounce the light deeper into the building and be used in smaller applications to floors, such as schools and single-story buildings. I looked at the louver systems in more depth, and basically these are a fully automated system that's controlled by the building, but also by users in the space. So the community spaces, conference rooms, and other breakout areas have these louvers that give control back to the employees of the space, so they can actually choose to shut out more light or let more in based on their particular feeling, but it's also driven by the building, so at the end of the day, these reset or they perform based on the location of the sun. You can see I actually went through and designed some of the details for how these louver motors work and how the 2 different gear interchanges work. So here are some of the site studies, and the existing conditions are on the left. The winter conditions are on the lower part, and the improvements are on the right. And you can see as you go throughout the day that particularly in the winter, that these conditions are almost intolerable. Yellow is good, yellow is bad, greens and blues are good. And you can sort of see how that transitions through the day. And eventually, through tweaking these programs, I was able to make an improvement for a more even diffuse flow of light. Now, if I had more time, I'd probably be able to make an even larger impact. And you can see from this section here that this is sort of the fiber optic system that I was talking about. And you have that sort of light catch element right there that in detail looks like this. And these mount to the exterior of the building and allow light to flow back deep into the slab. And this is a hybrid system that's then worked in with the natural LED lighting, the artificial LED lighting, so that when the day is not as bright or the ambient light is not as high, the LEDs step up and sort of keep the consistent, even lumen count for the entire workspace. But on really sunny days, we're using less lighting and less power, and it's better for the building from a performance standpoint. And the natural light is all around nicer in terms of working. I was also able to add almost over 3,500 square feet of photovoltaic arrays, going by the general rule of thumb for Bosch's current panels. You need about 100 square feet per megawatt or kilowatt per year. So I can generate up to 37 kilowatts per year just on the southern facade alone. Here's a detail of how that sort of system breaks down. And although the louvers are fixed, they do have a slight rotational mechanism that allows them to track winter and summer sun paths to gain the optimum efficiency, the average being 38 degrees for the DC area. Moving on to wind, You have the vertical turbine elements, which I developed to sort of take advantage of those currents that bucket along Cave Street. You can see some of the initial urban and close-up wind tunnel studies, and I used sorry to do these, to look at sort of the existing conditions there. And while this is not a huge generator of power, it does capture some unrealized potential along the facade. And there is sort of an axiometric breakdown of how the system works, and it's basically these long shafts protected by this vent system, and these shafts then are tapped into alternator-like generator that allows for production of power. So from the plant element, not as complicated as some of the others, admittedly, but it does bring life into the workplace. Plants, for example, have proven to help regulate air quality in work environments. They keep the air more a nicer humidity so it doesn't dry out, and they also help increase productivity according to John Burr's survey and study. The systems are not just for looks, however, they also filter stormwater runoff from the building. They use a specific set of plants, in this case English ivy, and several other grasses that pull all the organic compounds out of the rainwater as it sort of filters down and feeds the system as it drips. And then the idea being that once the water leftover excess water that sort of permeates the bottom of the living wall or the vertical bioswale then goes back into the city's sewers cleaner than when it started as the acidic rain and the polluted water coming down from the sky. These are held in with a basic structural system with trusses that then tie back into the existing column structure of the building. Again, I was trying to present a sort of realistic scenario that was a renovation that was doable versus something that was over the top. So moving on to sort of the last category, we have air, and this is one that I particularly enjoy. For me, the air was more about regulating the quality and the type of space, so I'm using ProSolve 370E, which is basically a titanium dioxide heavy, or it's a nanoparticle coating with this element that pulls smog and other pollutants out of the air via a catalyst reaction with the sun. So while I'm using these sort of panels here, you can see in this model, to shade portions of the building, particularly the northeast and the entrance over the lower level bank area, I'm using them as well to sort of create this press filter that pulls air through in this open manner and cleans it as it runs through these perforations through the facade. So you can see there it's what the system overall looks like, and then when we zoom in, you'll see that the sort of shading devices have these thousands of perforations, and that's to help increase the surface area so that the coating has the maximum amount of area that can work. And then there's some of this data. And this was developed by 2 students in Germany, an architectural firm, and they put it to use in a hospital in Mexico City in this format here, and that's why I'm showing you those particular panel pieces. I wouldn't necessarily use their particular abstract form. The material coating itself is still applicable to this project here. And then, of course, the double skin system and natural ventilation element of the building is another important aspect. So giving people in those, again, community rooms, conference rooms, lobbies, that sort of area, the ability to control their own immediate microenvironments, so that if they are too hot from the HVAC system, they can open a window and allow that sort of natural breeze to come through, or if they're too cold, they can be saved if the weather permits in DC. And I know that can be a difficult ratio to balance. So that is.
Can you tell us about what drove the placement of each of these systems? And then also, I'm curious, do you think that there's potential to combine several of them into one system?
Yes, I do think that there's potential, and I actually did a number of studies like this that show the sort of various areas for different, beginning to show different placement options. So I looked at where the wind flows were, and I looked at where the sunlight hit the most. You can see in the sort of shadow studies I have up here that in the winter and in the summer that the top portion of the southern facade receives a lot more energy year-round, and then the northeast actually surprisingly receives a lot of winter light that I hadn't anticipated before. So using those sort of diagrams, I did start to think about where that's what drove that placement. As far as combining them, I thought about how sort of to integrate the systems overall with the side, but not necessarily taking it to the next step. I suppose you could apply the coating, for example, to the louver systems that are forming this sort of double skin on the building as well, to allow that to help reduce some.
How did you assess that they would in fact contribute to the rate, rather than meet just their own goals? I think your premise at the beginning was that they should be able to contribute back, give more energy, have excess energy savings that come.
While I didn't break down the solar studies, for example, to the photovoltaic studies, to that sort of energy output benefit, it was my assumption that at peak hours, the building would be able to put some power back into the grid, and that when it was off peak hours, that the city would provide. So it's sort of a give and take. As for the air quality and the water quality, that's purely the building just does its job by filtering and cleaning it up, going back into the city cleaner than when it received it.
I think this is a very interesting way to structure a thesis, particularly stepping into a building that already exists and thinking about the project of reskinning. So I think there's hopefully that it shakes people up back there thinking about this is a little bit different than what we usually see as a thesis, and I think it's good in its difference. At the beginning, you talked about the human scale, the building scale, and the urban scale. Mm-hmm. And so maybe you said, maybe I just got lost at one point, but it seems that most of these propositions are about the building scale. And I'm left wondering, what is the contribution at the human scale, and what is the contribution at the urban scale? And you may have just said that those are important things, and then I'm just going to put them aside and look at this, the building scale, and because my hearing isn't totally fantastic.
Well, the contribution at the human scale is the better work environment, so a healthier workplace, with better lighting conditions, control over shading and natural ventilation.
So I can see that as being the implication of this, yeah. But what I'm looking for is kind of proof of the pudding. What I'm looking for is the interior views that are kind of the gestalt of all of this. And while there are a couple of interior views there, they're cropped, those are really about the skin.
Right.
They're really, those views over there are not about the changes of the work environment that come through. And so it seems to me that you've done a very nice study that's very analytical about moments that take place on the vertical surface of the building and create, this building's been recently built and it's got a fairly boring skin to it. And, that's what to say. It's a much more animated skin that you've created. That's probably much to your success in it. But I have less of a sense either urbanistically as to what the value added is there. And then I have less of a sense, I would think that there'd be a more robust depiction of the quality of light, of the kind of space that's inside here. Something akin to the image you showed of the NPR offices. Right?
I mean, from an urban standpoint, the implication is there that the building, by taking this building and then applying this sort of approach to design to an urban scale, you can improve the quality of the city's air and water and all the other various aspects of it on a massive scale, starting with one small single building block. But at the same time, looking at could I improve the immediate surrounding environment using these coatings or the way I filtered the water? So from an urban standpoint, it's about taking that building and then not just stopping at, okay, the building does a really good job of regulating its own energy usage. Now what can I do to help produce a better quality environment for the city around it? And that's sort of the urban idea from this.
I have a true fact-finding question for you. You said this are your pictures of your solar. How much do you improve in terms of depth from the scale by putting your design? How much is the sunlight coming in terms of real things? Because you use real software to do it. The other one is I'm still trying to understand the wind. How many days in DC do we have wind, which we can potentially use? And how far will the wind spread, or is it just we're talking about more comfort inside, or are you talking about using this wind inside the mechanical system?
Not necessarily using it in the mechanical system, but using it as a power generation element, so that there are usable winds sort of from a western approach, and in the fall to winter months, there are usable buckets, and the wind tunnel that K Street creates is also you get gusts that you can use to sort of turn these elements.
So did you look at the chart and see how many days in the year, or near basic analysis?
Yeah. In fact, there's the windrows for my specific site right there, and that sort of examines where the potential wind power can come from. Again, it's not as robust as I would have hoped it to be, but I think that the potential there, especially given the fact of the shape of K Street being so rigid, allows for more use there.
Because your thesis is more analytical and more numbers, I'd like to know what you're talking about in terms of power generation. Because power and wind is a huge thing. I could cover this whole building, or am I talking about just moving a turbine, or am I talking about a little fan? So do you have anything which helps me understand that this tunnel wind which comes from the device you design is going to help my building by what much? I'm not talking about money, I'm just talking about usage.
I don't have power numbers for the wind. It was hard to assess how much power those potential gusts could create. But I was sort of I was looking at how to actually build the specific piece with the hopes that we could exploit that.
There's a reason that most wind turbines are out in the open space, because they want clear laminar flow, and the power you get off drops off with the cube of the wind speed. So if you're not at the rated wind speed, you get almost nothing almost right away. So it's difficult to do that and generate a lot of electricity. But
I think this kind of thesis, and one I think we saw just before this one, that tend to look more at technology and look more at research opportunities. I have to keep reminding myself where I am, because this is a school, and these are students, and what they're looking at is recognizing the potential of things. But the claims, on the other hand, imply that they've actually answered it, that I'll have net zero, for instance, energy usage, or this will contribute to the grid. And I have a little bit of concern that the implication is that the answer is, yes, this is beneficial, whereas the answer could be, there are not enough days to make this work. So I just wonder, when we go toward the area of a research focus for a thesis, that maybe we don't tend to be conclusive on it, but that we just point out the areas where the investigation might occur, and where further research would answer the question that you're asking. Can I retrofit a building in a way that it creates a better internal environment, a better urban environment, contributions to the grid of the city, from an energy level. And that's what I see these last two projects are doing, pointing areas for research. But I think in the way the thesis sometimes is presented, it's implied that the conclusion is also built in, that yes, I did, and here's how I proved it.
So Gary, maybe one way around that, I think it's a very interesting point. I would hate to just say, let's not
Absolutely
dig
not.
into this stuff. I wonder what one way to do that is to pick one of these propositions and go deeply with it. So that if there are 4 different areas of concern in this building, is to pick one and to know about that in a deeper, more statistical way, so that you just have, so that what you're proving there is that you understand the methodology to get you
Yeah,
there.
exactly.
And then you might not have to do it for everything, but you do it for one thing that allows you to have enough depth.
And you might avoid making claims that go into questions in the backs of our minds.
Yeah.
And you know, the other possibility, because I agree that it's great to see this, such a range of inquiries in the process in general, and you are exploring this through a variety of mechanisms at a kind of tectonic scale. But I wonder if you might say, okay, this is the one system that I think really has some potential, and how do I test it? Like, build it at full scale, figure out where you can mount it, figure out how you can monitor it. Because I think then that addresses like this whole methodology that, and a true kind of experiment that we have the luxury to do in school. The other possibility here, I think that it's really interesting, like you mentioned, this idea of latching onto existing infrastructure and how you do that. And in a way, I think that you could, when I first saw it, I thought, this is a little strange. It seems like it was different designs by different people, and could it be sort of combining two of these systems or three of these systems? But the other approach would be to say, here, I'm being really opportunistic about the entire city, maybe not even just one building, about how the sort of objects of the city or the infrastructure of the city or buildings under construction might be the perfect opportunity to sort of make an insertion. And I think in that sense, it might take some of your ideas and you might tie them to a particular standard of construction that's, in DC in particular, it's governed by a lot of influences that give it a kind of a grain that you can count on, like the Florida ceiling height and concrete. But maybe there are other things like light bulbs, posts, or other infrastructures of the city that you can think about.
This is, to me, a very...
Wait, hold on. Richard, come on. This guy is so as a kid and as a parent, I was a reader of Winnie the Pooh, right? This is the Tigger. This guy's energy level and his willingness to tackle the biggest problem is just absolutely astounding. So the reason I thought of did this is because he's been doing what you're talking about. In other words, he started this thing with this outrageous statement. We got this city, all these facades are boring as hell. What were these people doing? They all look the same, et cetera, et cetera. They're not doing anything positive. And meanwhile, there's all these guys running around ripping all the old facades off and putting new facades up. And it's not really making any significant difference, and I can do better. We can do better. This is where he started, right? Okay, come on. So, all he's doing, this is just one example of what could happen in the whole city, was his idea, right? That he's not telling you about, because apparently we beat him up so much that, he's being too...
Just the imagery
polite
of
and
it
whatever.
is
So,
good.
come on, Richard. Richard.
You're bouncing up and down.
I saw this project as a way to sort of open the doors to a discussion about making an area that has a lot of potential live up to that potential. How do you take something that you keep pushing with this thin flat facade and make it something that actually earns its keep in the building environment? We love to talk about sustainability from the standpoint of putting these lovely, green roofs on buildings, whether they're intensive or extensive. We talk about, how many gallons of stormwater we can collect in those, but what's stopping us from then applying that to the vertical surfaces of these buildings, particularly an office building, where, I know there are a lot of very nice office buildings out there that are designed, for clients specifically, and they have very large budgets, so they get the nicest finishes. But even those nice buildings, don't have any sort of give back to the urban environment that they're in. So that was the whole point from an urban perspective, is how do you start that discussion about creating these buildings that actually put some stuff back in. And even if it doesn't, I'm not saying that I have all the solutions or that I solved this problem or that there's net zero buildings, but what I am saying is that by doing this, we're going to be doing a lot more for the city and the building than just, putting up this year's most effective performance efficient glass panels we built. So,
And Washington DC, with its 10-story building height, is a pretty perfect place to do this because there are predictable wind patterns. I mean, they're not going to change because somebody comes in and builds a 30-story building. So better Washington DC, it's a more stable kind of environment to do this than Baltimore.
Friendly amendment on the windmill thing, take that cover off and show the vertical axis windmills there so people can see them spinning around in the wind.
So Richard,
Yeah, but part of this is that it's not meant to just be a demonstration model about, look, we got something spinning on the roof, it's making energy, right? Part of it was that because I questioned that at one point too, and the answer was that it was more efficient to have it contained so it doesn't have debris, it gets on the blade, it doesn't have the whole other thing.
design the system to work on this sort of vertical surface because of those height requirements that we talked about. And again, it's, I'm not saying I have all the answers, but I'd like to think that if we were able to invest in this model, maybe a little bit more than the economics-based model where it's max out the rentable area to charge the tenants as much as you can. If you're willing to sacrifice a few hundred square feet, and I mean, even this particular case, I was able to get the linear footage up for the actual perimeter wall, so that increases the value somewhat. And being able to use this not only as a sort of saleable standpoint for renters, but also that you're improving the space internally and externally was really what I was arguing. That we should not be using these glass facades.
Richard, based on the enthusiasm, and I agree with you in terms of like the ideology of it all, I'm with you. I don't think anybody in this room is here to say no to you about that. So I guess the question that you make a claim that the building is better as a facade. I walk past this twice a month, back and forth to my allergist as I go visit this time of year quite a bit. And I'm looking at something that certainly would capture my attention far more than what's there. Right. So the thing I want to know is there a way to show imagery that shows sort of Jenny Craig before and after that now this building is all bulked up and ready to go, and this building has now contributed to that urban streetscape. Is there a possibility of having some measure of, let's say, the wind turbine, and going back to how many days a year can it be productive, or even if we don't know that, what is just simply the productivity if you have a good day out of this thing? What do we estimate kind of ballpark out of this?
But the way I'm seeing this thesis, I'm seeing it a little bit differently, because I've never seen a thesis where you actually improve a building. At least I've never seen one like that. I've seen always different kinds of things or renovations or something, but not kind of like this. I see it like this is a menu of things that you could do in buildings, and you chose to show them all, like in this particular one, and sort of said, okay, this could all work in this case. But the reality is perhaps not all of it would work. Maybe the wind turbine would not be fit, or maybe the plant element would not be fit, because whatever. So what I find interesting about this is the options that you're giving to someone. And frankly, you, as trained as an architect and going to practice architecture, you're not an engineer. Okay? You're bringing a different view to this problem of recladding office buildings and recladding buildings in general. Things about office buildings are they're all or most of it about skin and lobby, right? They're shell buildings, and they're about prestige, and they are even classified in finishes and prestige. You have Class A, B, and C, right? And the way the buildings look is a big deal, and that's why architects, sometimes get great commissions to do these great elevations and facades. So when you combine in things that actually function for a social cause, for society in general, to clean up the air. You're not cleaning the air for the building, you're cleaning the air for the city, right? So that is that's great. But in a financial model, what advantage would that be for the person actually paying to do this? What's the incentive? I think that's a great discussion, and I'm not going to get into that. Plants, all that. So I find this very intriguing. I work in a building right now that use that turbine because I know the winds around it are amazingly strong. You can't even walk sometimes, and that would be great. In other buildings, that would work. The thing that you bring, let's say this is an idea that takes on, you bring exactly what Brian is talking about, which is the architecture, right? That's where the city becomes this, what you call the building scale, the urban scale. That's where you bring your hand and your design, and you custom this thing to a particular site, a particular building. And the engineering of it, the motors, the fans, all that, that's it. That should be pretty much mechanical stuff, right? Right. But you bring the creativity and how you insert this on the site. And I hope you're not proposing that this would look identical for every building.
No.
Right.
The idea is that you use this, and really this is just scratching the surface for the potential of different systems. But the idea is that you have these sort of standards in place, or these sort of systems in place that you could then use based on the sort of analysis of your particular site. So like you're saying, more wind equals more of these wind elements.
I think ideas like this are very interesting because they trigger changes. There are things that I talked about, the social cause of why would you do this? And you could convince the city, for example, to give tax credits or to give you extra FAR or something if you put this kind of devices on your building. All of a sudden, you're actually making it work for real. Because now is to the interest of the developer to put these things there because there's an incentive of doing that. And with that, we all benefit from it. So this idea can actually generate a lot of money.
And we do this, we do it for plazas.
It'd be great for all of us.
The sidewalk treatments for buildings. So I think this would be the next step.
Yeah.
I'd like to point out one of what I think are the triumphs of this list, and that is that you've studied it, pricked out the actual material and assembly implications of your sustainable strategies, and that you've taken the physical reality of a DC office building in a fairly generic sense. I mean, this could apply to so many buildings, and you've really looked at what it means in terms of what the parts are, how the parts join to the building, and I think that you've taken this project farther than we often see in a thesis, and I think that that's an important aspect of what you're doing. So, yes, you haven't quantified it all for us, but you have used the software to run some tests, and I think that this is an exemplary project in the variety of ways you have dug in and tackled these sustainability strategies. So I think you've really gone beyond greenwashing here, and then you've looked at, okay, what are the real implications? How's it going to change the office building? Not just in terms of renderings. Yes, you could have shown us the inside, you could have shown it from, the kind of street level view of the city. And I know you wanted to get there because you had enormous ideas. But I think it's important to point out that what you really have done well is you've taken us right into that facade. You're not just looking at it as a wall, but we're including your drawings. And you delighted in the pieces and how they come together and make these dynamic aspects really functional. Actually, that's something else you could have shown us that would be interesting, rather than a static, thin facade, you've given us one that's responsive,
Right.
that actually operates. And you've also, I think, underplayed the way in which you've proposed an architecture in which, no, you can't build the same facade on every side of the building, that you would produce an urban area in which we felt oriented in the environment because of the way each facade worked in tune with the sun, the wind. We would see which sides plant life could grow on, which sides it couldn't, where it's possible to generate wind. We would become, I think, more aware of the environment because of this type of architecture that you've explored for us.
There's a building in Baltimore that might be worth your seeing. I mentioned it to you. I wish I could be better at remembering names. The German architect who just did the University of Baltimore's law school. Yes. And in
Took
that,
Adam Gross, it's Adam Gross.
I know that claim as well. But it might be interesting for you to study, and in that respect, you know, the discussion almost suggests that this might have been, these systems might have been a better test on a building where you controlled the orientation and placement of the building and had to respond to other conditions. You're lucky, this has a southern exposure, so you have all the, you have set the parameters under which you would explore, but some buildings have other exposures as well, and they would have different solutions. And the interesting thing about the building in Baltimore is that it uses some walls, double glazed walls that are sometimes a foot and a half apart from the two planes, and then uses other things to respond to the orientation. And I just would suggest that maybe a test, you could have done this in a number of ways. The fact that you limited the test by taking an existing building, I think causes us to look at it a certain way versus if you had a building and your solutions responded to the building's, all of the building's conditions, including its roof.
So if we elaborate on the strategy, at one level, what he's got here is he's got a process which is applicable across the city of Washington, D.C. One can imagine, so he did detailed wind studies of what happens on the street. Had he been, if I remember correctly, had he been doing the building on the opposite side of the street, the wind velocities were not great enough to drive this turbine.
Right, so it was,
So it's, you know, in that sense, it's place specific. But what that also means is that if you go do the wind tunnel study for the entire office district of Washington, D.C., then you know where the wind velocities are strong enough to drive these turbines, and it tells you where you might go about encouraging people to do the kind of thing that Antonio was mentioning, is that you figure out what the incentive system is. We talked here a little bit about the idea of encroachment. You know, that you get a little bit more floor space, which is of course runnable floor space. By allowing an encroachment, it allows you to punch this stuff out as you're going around these facades, for example. So the fundamental idea here, I think, that you're kind of talking about, but I just want to make clear, is scale. It scales up to the size of the city. And so don't, you know, all I'm saying is don't get too trapped in what he did in terms of taking a specific example in order to be able to test the broader model.
The police suggestion is, like he said, this wasn't meant to be in fact, we like to know what calories are in it. If you would tell us this is good as a dessert, that's good as, you know, appetizer, tell us the pros and cons of everything. As much as you can. I know you're limited in time. It is incredible the amount of detail because I mean, all of us have that capability to get that technical and know all the systems. So you have the interest, I think, as you move forward. Remember, any system is only has its good and it has its bad. And as a student, as an architect, as a person, we need to see what that is. And so if you brought this, if you told us you planned, this is okay if you put it at 10 feet, 30 feet, 50 feet, it doesn't work at 7 feet level. It's all good. Something to quantify your research rather than just pictures. This will help you to get the sun's depth 12 feet. And if I have a conference room there and I don't need 12 feet of sun on my face, I know I can't do that. So kind of any little thing to add more value to that room, the time you spend, so that you can and everything else you make an informed decision from your business. So moving forward, maybe taking a few minutes and writing notes for yourself, because as you get into the career, you can use this information.
I think Antonio touched on a point that might suggest where the future of your thesis might go. Right now, I think Exelon Corporation, which has bought all of Baltimore Electric and Gas, is now trying to buy all of your Pepco stuff. They're building a new headquarters building in Baltimore on a boring building with a skin that does nothing. When they came before our design review committee, we challenged them, why does their building have no response to energy issues if they're an energy company? and I just suggest that I don't think it's the developer who, or the city who would give this benefit. I think it's the energy company that should be buying the energy that's being saved here. I think the energy companies would be the partner in the skin and looking at the potential of the skin and how you deal with it, how you finance it, and how you gain from it. Because nobody's going to invest in it unless they gain something.
Absolutely.
But Gary, I'd like to just say, I think it's the owner of the building, I think it's the energy company, and I think it's the city.
And partnership.
In partnership. I think we can begin to think of this a little bit more systematically.
Well, I think so, because with this, the city, since they don't usually have the money, they can offer tax incentives,
Yeah.
things like that.
Well, and the city can also allow the encroachment more from the face of the building.
Which I must admit, in the back of my mind, is somewhat of an issue, because some of these, like this one right here, suggest that an existing face of building is going to have elements that project what looks like 4 or 5 feet from it.
But currently, it's allowed.
No, I'm just saying though, out into the edge of the urban environment. It gets back to the question raised earlier about on how many different levels do you look at this urbanistically as a pedestrian walking along the bottom of the building with things dripping on your head from overhead. You know, so what do you do in the design of this to create a full building and not just a building skin? I think some of us cringe at just reskinning a building rather than rethinking it on all of its levels.
Actually, I
Right, but the.
because I think that you could have solved some of the scalar issues here with thinking about how the ground plane of the building works. What people see when they're walking down the sidewalk and so on. The window plane is generally about maybe 3 stories. And how is that scale different than what happens above that?
But that would have introduced a discussion about landscaping on the streets. That would have presented a question about cover and shade. That would have presented a question about how you differentiate the office from the retail below. And you have an opportunity by adding this skin to deal with the entire building and its environment, not just the skin.
And maybe the answer is that there's a different skin at a lower level than there is a skin at another.
And I would hope so.
But I'd like to encourage you to think deeper, because I think you've separated these without thinking about how to do it. Because I don't see a light shelf here to go light that in.
Look at one of those.
I see it maybe based on the fiber optics. I see that you penetrate in some places, I hope to have in others. And so if you can get the facade and have that to work on a more regular basis, how you can introduce water and rain capture into this, how you can use the chain effect to capture that with a heat recovery wheel, and to get to really think about this as a living facility. This gets back to process. I think by thinking about them as individual things and not thinking about it as a whole system is where I would encourage you to take the next step.
There's another aspect that I'm going to go out on on and just I think that a lot of these things in the future, maybe not so this is going to be dated. People are going to say, these people were doing this back in 2020, whatever. Why? It's the same thing as when airbags showed up in cars. The car companies would boast them. Airbags, now they're standard, and they're hiding them, but they're there, they're functioning, and thank God they're saving lives, right? I think the green features are more and more becoming code and more becoming part of daily life. And I think one thing that doesn't change is you're an architect. These things, to me, are means to an end, and I think eventually I want to see a building. If the facade is working, it's awesome. But do I really need to see things all the time? Do I really need to know it's there and it's green and it's leaking and it's doing it? No. I mean, I want to look at a building and I think to be more sustainable, more financially interesting, and more attractive to many different owners. We have biases from all kinds of. You want to design a building that's fantastic, and these things are so flexible that they blend almost imperceptibly, and then it becomes timeless. Then the fad of the green stuff, which is beautiful, and at one point, actually is something that works. I was in Portugal not so long ago, visited the building that my brother bought an apartment on. The building at Louvre is similar to this, on a corner. And I couldn't figure out what those louvers were. I was like, what is this one? He's like, you don't know what this is. So we walk inside, every unit had a corner where you could hang clothes on. Really? That was just to hide the clothes, the hanging clothes, because the city doesn't want to see hanging clothes. And now there's an architectural solution to something that was terrible. And still people like to hang their clothes if they can and save energy because they're not using dryers. And so there was a solution there. And I think the same thing for the green stuff, perhaps, is something that could be explored in an architecture.
Let me just defend you for a minute, because I don't think this is actually so different from what you're saying necessarily, but I think it's critical that we have people looking at this and trying to kind of invent new, down to the system scale, new ways to build. And I think that's how it becomes integrated in a way that we don't think about it so distinct anymore, is by saying, I need to design at a much finer grain of detail than just accepting what's available, because otherwise we're never going to solve these problems. I think for me, I really think that integration that you talked about is the next step for you, because
I mean, this is version 1. Right. Of hundreds of thousands.
But I think that if you start to think about the gradients of the systems and how they can become one system that could be opened up, whether the more kind of public space that you want to be visible and closed in another area, and greater where there's more wind and with more sun, then I think you start to really make a dynamic system that enlivens what you were complaining about, the kind of visible, functional, aesthetic version of what we consider our system.
But Timberlake has designed a double wall system within the same depth of the standard curtain. So we know technically we can do that. So as we begin to think about walls, the questions need to be brought up in a sense. And I think, picking up on what Jen was saying, is that we continually need to keep up with what's going on and push it to the next step.
You mentioned, before you mentioned 3 groups that you could see being involved in this process to make this kind of thing happen. One was the owner,
City. One was the city.
one was the city,
And one was the energy.
and one's the energy company. I want to add I want to add the manufacturers of these various devices, where they're interested is simply in selling them. The sales folks that sell them. The people that whose livelihood is derived from installing all these things in complicated ways. And I think, if I remember this correctly, this gets to the personal driver. I mean, we saw earlier today personal drivers. Richard's worked on these buildings because his dad back here, if I remember this correctly, does a whole lot of this kind of work. that he is, in fact, in the construction industry that reskins these buildings that Richard's had direct experience with. It's the combination then of that larger group of people understanding together, getting together and understanding that this is an opportunity that actually can happen. And here's a process and a procedure that allows that to begin to actually have that transformation, take place. With that, Mike Lambros was the chair of this committee. Madeline Simon was also on the committee. Closing comments?
Matt, you have anything you'd like to add?
Oh, I think I gave my comment earlier, but I could just add that I enjoyed this thesis so much because of my passion that I share with you for building skins. So thanks for giving me the chance to think about it this past year.
This is just the beginning, hopefully.
Well, I think it provoked a great series of questions today. I think it's remarkable to have a young person about to embark on his career asking these kinds of questions. He's not making a fanciful piece of architecture that's just a folly of his imagination. He's trying to solve real problems. He's looking at the world as it could be, not the world as it is. I think you all asked him a bunch of questions that I would say we really should be asking the profession, how we've let it get to this bad or dire state that his fathers had to build these things. How it is that an energy company thinks that they can build their headquarters in the region and not address energy. All of these things. I mean, we think about all the people that could play a role in this. We can play a role in this because things like the airbag was mentioned as an example. That technology existed and there were guys out trying to sell that. There were salesmen going around the world trying to get some car manufacturer to put it in. It wasn't until they did the research. It wasn't until a university student like Richard presented the research that said this saves lives, it has a measurable impact, right? And many, many things. Windshield wipers at one point were an option on cars, right? So these things happen with days like this where we say the world could be different. And I think that's the most rewarding part of your journey here, Richard, is that you've always said the world could be different. How could it be different? You've looked at 4 ways it could be different. I wish that maybe we brought him a little maybe strategically, because I know he does have the answer for how much deeper he's gotten the sun in here, both as a distance and a percentage and a little value. We've got a cool color diagram to go with it. He did answer the question about wind, because I said, I walk there all the time, there's not enough wind there. He said, yes, there is enough wind there. And he first modeled the city, he modeled this. I'm glad he brought it here today. I said, Richard, that's not the city. That's not what this is. This is an island of a piece of the city on a plate, and the wind doesn't move around it like that. And he came back and at least gave me the neighborhood. He didn't give me the whole city, but he's asked those questions. And to all the students in the background here, this is how you set out a premise, have a research question. Can I move the needle on solar? Can I move the needle on renovation? Can I move the needle on whatever the issue is? He's tested it. He has those numbers. He's looked at it. But I'm glad in some ways you took your licks today by them saying they wish they knew the numbers. We know you have the numbers. We know how many 1 inch of rain on the square footage of this, how much runoff is going to feed those plants. We know how many gallons that is. You didn't think that was important. I didn't think that was important for you to know today. 287.53 gallons. There you go. That's not the important part, right? The important part is that you said, can, again, architecture change the world to make it a better place? Can I come here and work my 60 to 80 hours a week, depending on where you work in D-State, and have it be a better place? Can I look outside and see something green and growing that's living in this world with me? Can I do something that's going to move the needle on the world? And that's fantastic. And I think to all the students out there, this is how you set up a research question and how you say, can architecture fix X?
And we're going to go look at another one.
We're going to look at another. So thank you, Rick.